Okay, folks, welcome to lecture 5. And in this lecture, we're going to take a look at cancellation. And then we're going to take a look at fraction operations and some complex enough fraction problems. First, though, we'll just take a look, get this sorted. We just take a look when sums go bad. So on Scott's expedition to the South Pole, he calculated his men would need 4,500 calories a day. That's about double a normal man's ration. Normal man is about 2,500. Unfortunately, it was a bit of a miscalculation and he was short about 3,000 calories a day, just due to the high altitudes they were at and the level of exertion with hauling their sleds. They didn't have dogs. So essentially there was a deficit of about 3,000 calories a day in Scott's calculations. So by the time they actually reached their goal, the South Pole, they'd lost about 25 kilos of body weight. So they did achieve their goal, but on the return journey then, it's presumed Scott and all his men died of starvation. So it's just, guys, to show that kind of calculations, or certainly miscalculations, have consequences, and sometimes those consequences can be fatal. So do be careful. We're going to take a look at cancellation now. It's one of the most important skills you can develop. I've designed an awful lot of the module with cancellation in mind, so if you cancel as you go along, you'll find the maths is a lot easier. It does require a bit of practice, and it's very important to know what you can and can't cancel, but we'll discuss that as we go along. So firstly, what is cancellation? It's simply dividing the top and bottom of a rational term. Now, a rational term is anything that's like a fraction type yoke, as I call it. But it's crucial we divide the top and the bottom by the same amount. And it's how we simplify fractions. So if I gave you this fraction here and asked you to cancel it, so just have a wee go at it, guys. You can pause the video. And then on the next slide, I'll just discuss the process in a little more detail. So here's our fraction. And what we actually want to do, guys, is figure out, well, what are the factors? What numbers multiply together to give me my numerator? What are my possibilities? We could have 1 by 24, 2 by 12, 3 by 8, 4 by 6. So all of these numbers here are factors of 24. Now we could do the same for the denominator. What are the factors of 72? 1 by 72, 2 by 36, 3 by 24. And these are all our factors of 72. Now we could go along and we could say, well, 2 is, we could divide the top by 2, divide the bottom by 2. And then we could go by 2 again. But it's just going to take ages. So what we're always looking for, guys, the most efficient way to cancel is to divide top and bottom by the highest common factor. What number is common to both sets of factors? And in this case, it's 24. So if we divide the top by 24, we'll get 1. We divide the bottom by 24, we'll get 3. So that, guys, is when you're cancelling, you're always looking to try and divide top and bottom by the highest common factor, the biggest value that's common to both numerator and denominator as a factor. So just a few tips, guys, kind of this is handy to know. So first of all, how do we know a number is divisible by 2? Well, it's fairly easy because the last digit is even. If this last digit is 2, 4, 6, 8 or 0, we know we can divide the whole number by 2. Another one everyone knows is, well, how do we know a number is divisible by 10 if the last digit is 0? So we know this digit in the top right corner, this number, is divisible by 2, and we know it's divisible by 10. It's also divisible by 5. If it ends in a 5 or a 0, then we know it's divisible by 5. So most people are familiar with those. How do we know if a number is divisible by 3 though? How you know a number is divisible by 3 is if we add up all the digits. So 6 plus 6 plus 8 plus 4 plus 0. So this is 12, so that adds up to 24. If the sum of the digits, so this is the sum of the digits, if that number is divisible by 3, then the whole number is divisible by 3. So the sum of the digits is 24. 24 is divisible by 3. So this number we would suspect, well, we would expect to be divisible by 3. This goes in twice, 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 2 left over, 8, and then the 0 just drops down. 3 into 0 goes 0 times. So the number is divisible by 3. How do we know a number is divisible? Here's another number. And again, this is divisible by 3. Add the values up, and they add to 9. 9 is divisible by 3, so 3 will go into this number. With 3 times, 1 left over, goes 4 times, 1 left over, and goes 4 times. So it's the sum of the digits, guys. We add all the numbers. How do we know a number is divisible by 4? If the last 2 digits are divisible by 4. So 32 is divisible by 4. So this number here, we expect to be divisible by 4. 4 will go in here 7 times with 3 left over, 7 times with 2 left over. It'll go in here 5 times with 3 left over, and 8. The number above, guys, is also divisible by 4 because 40 is divisible by 4. So if the last 2 digits are divisible by 4, then the whole number is. How do we know a number is divisible by 6? Well, 6, guys, if we think of it, 6 is the factors are 2 by 3. So essentially, we know a number is divisible by 6 is if it fulfills the conditions for divisible by 2, the last digit is even, and if it fulfills the conditions for 3, the sum of the digits is divisible by 3. So if a number fulfills both those conditions, then it's divisible by 6. So here, guys, the sum of the digits is 9. The last number is even. So we'll see if this is divisible by 6. 6 will go into 30, 5 times with 1 left over, 1, 7 times, and 2. So the last one then, guys, there isn't really one for 7 or 8, but 9. 9, guys, if we think about it, is really 3 by 3. So the conditions are very similar to this. But it's if the sum of the digits is divisible by 9. So if we add up all our digits, in this case we know this is 9. So now the sum of the digits is 9, guys. So I now expect this number will divide evenly by 9. Goes in 3 times with 4 left over, 3 times with 4 left over, 3 times with 7 left over, and 8. So that, guys, is just handy. Like if you're looking at a number You have a few little tricks now to kind of know, well, will 9 go into this number? Add up all the digits. We won't be doing too much with big numbers like this, guys, but it's just big numbers help explain it more. There's one more, guys. I won't expect you to know this one. It's my old colleague. Used to always love this one, so this is in honor of him. How do we know a number is divisible by 11? Say if we have a big number like this, guys, and we're wondering, is this number divisible by 11? What you do, guys, is you add the alternate digits. So I'm going to add these 3 together. And then, so I'll just show you here, I'm going to add the black digits together. And then I'm going to add the red digits together. We subtract these. And if our answer, guys, which in this case is 11, if our answer is divisible by 11, then that whole number is divisible by 11. 0 also counts. So if we say, even looking at something we'd know, 88, well, there's no real third number, so we just get the difference between the two numbers. 0, 8 minus 8 is equal to 0, and 0 is divisible by 11. So don't worry about that one, guys, too much, but it is just a handy little trick if you do remember it. The difference of the sum, so you add the alternate digits, the red numbers, the black numbers, get the difference between them. And if that difference is either 0 or divisible by 11, then the whole number is divisible by 11. So we'll just take a look, guys. We'll push on and show where this kind of starts to become applicable. Is without cancelling. So before calculators, every kind of school kid was very adept at cancelling because it just made your life much easier. So say if we were asked to do this problem. Now this is the fraction from 2 slides ago. We know it's kind of 1 over 3, but if we're asked to divide it now by this other number, well, we remember with our fractions, when we're dividing by a fraction, we flip and we multiply. And now, guys, again, laws of fractions, top by top, bottom by bottom. And we end up with something like this. And if you don't have a calculator, guys, straight away you're going to start feeling a bit ill. That's perfectly normal. And you might go off and go 108 by 24, and then go 72 by 64, and you're going to end up with a fraction that looks like this. And now you're really beginning to feel a bit nauseous and you're giving up. This is not the way, guys, I want you to be looking at maths. There's always a much, much, much easier way. And that way, guys, is to cancel. So even when things are complicated like this, when things are multiplied like this, guys, in the eyes of maths, it's seen as the one term. So on top, we have one term when things are multiplied, because they just give us one answer. Similarly, on the bottom, guys, we have one term. So in maths, as long as we divide the top and bottom by the same term, we'll just call it A, then we're preserving equivalence, equalness, and the value of the fraction is unchanged, only its appearance. So what we actually want to do here now, guys, is use that little skill. All I have to do is pick one number off the top and one off the bottom. So I can see, remember, always try and pick the highest common factor. That number there is divisible by 9. And so is this number here. So now 9 will go into 108. Again, if you need a little bit of rough work, bash away. Go in there 12 times. 9 will go into 72 8 times. Now we can, again guys, we can pick any number off the bottom. So I'm going to pick the 8 and the 24 because I know 8 will go in here 3 times and 8 will go in there once. Now here, I'm looking, will 3 go into this number? It won't because it adds to 10. But I can see 4 will go into this number and 4 will go into the number up here. So 4 will go in here 3 times and 4 will go in here. Always be careful guys, just take your time. It's not, it doesn't take that long. 16 times. So now guys, my problem has actually simplified down to 3 by 3 on top over 1 by 16. And that gives us 9 over 16. So with a little bit of cancellation, guys, what looked like a hideous problem can simplify down quickly. Now, say if I asked you at the start of the semester to get the square root of this number here without a calculator, I think most of you would have looked at me with disbelief. But we've already done this bit. We've done that just now. So that gives us the square root of 9 over 16. And now remember, our square root will come in, square root of 9 over the square root of 16. And that gives us 3 over 4. So we are actually developing quite a lot of math skills, guys, as we go along. So always look for cancellation. We'll see where it pops up again in some of the problems I have prepared on the slides ahead. So, don't forget to pause the video. Here's your question for the CA tests. So use cancellation, guys, to have a go at both of these. Now, there's a video up on Moodle and I do very similar examples to these. So if your head is a bit wrecked with what we've just done, go on to Moodle and take a look down towards the bottom, below the lectures at the bottom where the videos are, and you'll find a video on cancellation and we go over this again. And we do problems like this. So the main thing, guys, is start to kind of use the resources now as well. The lecturer will often just point you in the direction of a resource and you might have to use that resource to kind of get your practice levels up to where you need them to be. So I'll push on again. So have a go at those. They look horrible. These are actually exam questions. These used to always appear on the final exam. Quick overview, guys, of fraction operations. So we did this in the last lecture, but some of you might just need a quick refresher. If we're adding or subtracting fractions, first step, we must get a common denominator. Then we adjust each fraction. We multiply here above and below by 2, and we multiply this fraction here above and below by 3. So now we'll have 4 over 6 plus 3 over 6. So we adjust the fractions and then we add them as before. So find your common denominator. That was the 6. Adjust the fractions. That's what we did there. And then we add and subtract the numerators, but the denominator always stays the same. I'll just write those back in again. So that was addition and subtraction. Multiplication, remember, top by top, bottom by bottom. So 3 by 1 on the top, 4 by 2 on the bottom. Division, flip the divisor and multiply. So flip the divisor and then multiply top by top, bottom by bottom. Now here, guys, even though you don't realize it, cancellation kicks in here. And now we've got 3 by 1 on the top, 2 by 1 on the bottom, and we've got 3 over 2. So always look for cancellation, guys, before you multiply. Because otherwise we would have got 6 over 4, And then you're still going to have to cancel anyway. So you're much better off doing it early than doing it late. So that's an overview of fractions, guys. And now, again, these are just for you to have a quick try out. These ones are just getting your common denominator. That's the challenge. And then, guys, on problem C and problem D, don't forget the cancellation. Before you start multiplying out 18 by 24 and cursing me up and down the road, what will go into both those numbers? What will go into both those numbers? So cancel before you compute. Here, guys, flip first. And then you only cancel when you have a multiplication sign above and below the line. Don't try and cancel with the problem as it's written on the right. So again, guys, I'll let you practice them in your own time. Ideally now would be the best time. And now, guys, I'm just going to work through some trickier fraction problems. So if fractions are wrecking your head, guys, go on to Moodle, and again, there's 3 videos on fractions. If you want to see the fraction problems been worked out, then you want to look at the fractions practice video. Fractions method, then I take you through the methods we've just described briefly in the previous slide. So say we're asked to do this problem here, guys. Now there's a couple of things going on here. We have a whole number. We can take care of the whole number by writing it as a fraction, but we'll come to that a little bit later. First thing, guys, taking a look at what's going on, we have 6 multiplied by brackets, and inside the brackets is a minus. So in terms of BODMAS, guys, brackets comes first. We must work out the inside of the brackets until it's a single term, either a number or a fraction in its simplest form. So that's my first job. The 6 stays outside. I look for my common denominator, which is 6. I keep my sign, so that's my first step. I know my common denominator is 6 from 3 and 2. Now, guys, the left-hand fraction, I'm going to multiply above and below by 2. The right-hand fraction, I'm going to multiply above and below by 3. The reason is, guys, is I want to get this 6 on the bottom. And once I have that common denominator, both denominators are the same, then we can add or subtract them as normal. So 2 by 3 is 6. 2 by 2 is 4. That's the left-hand fraction taken care of. On the bottom here, guys, 2 by 3 is 6. That's what we want. 3 by 1 is 3. And we've already taken care of the sign here. Now, guys, I still have the BODMAS dictates. I still have to work inside the brackets. First of all, I have 4 of these sixths minus 3 sixths. My answer is still going to be sixths. Don't add or subtract the denominators. 4 minus 3 on top, sorry, I'm thinking ahead. 4 minus 3 on top gives us 1. Now we have the 6 waiting outside. We've reduced the inside, the brackets, to a single term. Finally, guys, like I said, I can write the 6 as a fraction. Write it over 1. And now it's to be multiplied by 1 over 6. And again, guys, cancel. I know it looks obvious. If we don't cancel, we're going to get 6 over 6. If we do cancel, we're going to get 1 over 1. Either way, the answer is 1. Next one. I'm just realizing there, guys, my thing said proper or improper fraction. Technically, a whole number lives, so whole numbers, just to talk about number sets, I think I have a little slide on it. Any positive whole number, guys, is called the natural set, natural numbers. Then any positive, so that's like a little circle there. Then, guys, any positive or negative integers, that's called the integer set. It's given the letter Z. And then, guys, all fractions come next. But all fractions, they're given the letter Q. Rational terms, they contain all integers and they contain all natural numbers. So technically, the number 1 would still be considered to be in the fraction family. I won't get into it too much at the moment. We don't need to worry about it a lot. This example, guys, again, we have BODMAS. We have a bracket, we have a multiplied, 5 multiplied by something in the brackets, and inside the brackets is addition. However, we have improper fractions. Can't work with them. So our first step, guys, is to change the improper fractions into, we have mixed fractions. Wrong terminology. And we need to change them into improper fractions before we do anything. So 2 by 1 plus 1, this gives me 3 over 2. Multiply those, add that. 10 by 3 is 30. And I add 1. That's what gives me my numerator. Sorry, that should be 31 over 10. So now I have top-heavy or improper fractions. The 5 is still waiting outside. Get a common denominator, it's going to be 10. Keep my sign. The left-hand fraction, guys, I need to multiply above and below by 5. Because I want to have the 10 on the bottom. As a result, the 3 gets multiplied by 5, so I'm multiplying the bottom by 5 and the top by 5. On the right-hand fraction, guys, we have 10 on the bottom, so there's no adjustment required. Now we add the numerators. And again, guys, if you want, you can cancel in here. Turn the 5 into a fraction. And again, guys, it's top by top, bottom by bottom. But look for cancellation. 5 will go in there, 5 will go in there. So my answer then is 23 over 1, which is 23. So again, guys, technically this would fall into the world of proper fractions because it could be written like that. Next one. Looks tricky, guys, but again, just keep BODMAS in mind. Don't freak out and take it step by step. So the 2/5 waits outside. Now, inside the bracket, guys, we have 2 operations going on. It doesn't actually matter which we do first, so I'm going to do the square root first. Square root the top. Square root the bottom. And similarly, guys, I'll just write these out first so that you'll see the general logic. So this is what really goes on. The square root and the square goes in top and bottom. I'll leave that line. Now we get 4 over 5 plus 9 over 4. My common denominator inside the brackets. Again, guys, the common denominator only applies when we're adding or subtracting fractions. We don't care about this thing out here. Sorry, my pen is... Oh, you're bad. Can I undo that? No. Sorry guys, my pen just had a momentary freak out there. So common denominator, guys, only applies when we're adding or subtracting numbers. So these are the ones I care about. The 5 outside, it's common, but it doesn't matter. He just waits his turn. He doesn't care about common denominators, doesn't need them. This fraction, guys, the 4/5, I multiply top and bottom by 4. That'll give me 20 on the bottom. The right hand, I'll multiply top and bottom by 5. So on the bottom, I'll get 20. On the top, I'll get 16. On the bottom of the right hand one, I'll get 20. On the top, I'll get 45. 20 is my denominator. And 16 plus 45 gives me 61. 2 is waiting outside. 5 is waiting outside. So these guys now have been multiplied. So we have 2 by 61, top by top. 5 by 20 on the bottom. Not a huge amount cancellation. 2 will go in there once. 2 will go in here 10 times. So we'll have 61 on top and 50 on the bottom. No common factors there, guys, so that is our answer then. So don't expect nice whole numbers all the time, guys. Kind of, you know, on Moodle and stuff, certainly when I'm using the random generator, you'll recognize those ones. They're the ones where you can draw in your answer using the mouse or whatever. You won't get nice whole numbers. So in science, guys, weird looking fractions, weird looking decimals are our daily bread and butter. So we'll start getting used to them here. So now, guys, one more. And then we'll throw up a few problems for you to try, and then we're finished. So here, guys, we have lots of stuff going on. I have an operation here. I have another operation. But here I've got brackets, so that's where my attention lies. Now, one way is to go 45 by 8, 16 by 30, and you can multiply those out, guys, but again, you're ignoring what I'm trying to teach you all the time. So here, this bracket, guys, look for cancellation. 15 will go into the top 3 times, 15 will go into the bottom twice. 8 will go into the bottom twice, 8 will go into there once. So that bracket, guys, if you cancel without doing anything too hard, you get 3/4. Now keep the sign, it's a minus. Remember, square root, guys, we can just get the square root of the top. Square root of 64 is 8. Square root of the bottom. And similarly, guys, we can square the top. 1 by 1 is 1. Be careful, don't write 2 there. And we square the bottom. 3 by 3 is 9. So a very common mistake, guys. People often write 2/6 when they square this because they kind of go 2 by 1 and 2 by 6. 2 by 3. That's not correct. Now here, guys, there's a few ways you can go. Get a common denominator, which is 36. But it's a little bit uphill. Because if you actually take a look, we have addition and subtraction. Doesn't matter which we do first. If we do add these together, we have 1/9 plus 8/9. That's 9/9, which is 1. Minus 3/4. And again, guys, you can go for common denominators. Oh, I need a 4 on the bottom. But if you think about it, 1 minus 3/4 is just a quarter. If you had a pizza and your friend came in and ate 3/4 of it, you've only got 3/4. You've only 1/4 left, and you have one friend that you'll never speak to again. So always, guys, try and kind of sit back from the problem and just take a look. I'm always trying to give you little shortcuts like that just to make your life easier. I understand how hellish maths can be. So I'm always trying to give you little shortcuts. If you can sit back from the problem, take a look. Sometimes you can slide to the finish without having to kind of climb a load of mountains. So next few slides now, guys, are problems that I would ask you guys to have a go at. You're going to freak out when you see them, but don't. This is one of my favorite exam questions, this type. I have a whole bunch of these. First thing, guys, is watch out for BODMAS. So the way to tackle this problem is to work out the top line until you've got a simple fraction, a over b. Then work out the bottom line until you have a single fraction. And now you have a fraction divided by a fraction. Flip the lower fraction and multiply. Watch out for BODMAS though, guys, like I say. Your answer, guys, should be a whole number like 3 minus 1 plus 1 plus 2 minus a half plus a half minus a third. So your answer in this case is, it'll be fairly obvious when you've got it out that you've done it correctly. If this is completely freaking you out, guys, watch the video on Moodle, and I've worked my way through a similar problem step by step. This problem is similar, guys. So again, this is one for your test. It's just to practice, guys. It's all about practice. They look horrible, but you gotta practice them. And like I said, guys, these are off your exam paper from the last previous 8-9 years. Exact same process, guys. But when you're working the top line, don't forget BODMAS. Similarly, when you're working the bottom line. Because if you ignore BODMAS, guys, you're never going to come close to the right answer. So always, guys, just kind of keep working away. Top line, keep cancelling as you go. Keep going all the way along. And the problem will get simpler. Only focus on the top line, guys, until you get that single fraction. Then, again, don't ignore BODMAS. Work on the bottom line until you get a simple fraction, and then flip the lower fraction, multiply, and your answer should come out nice. So last one then, this is the one that makes everyone cry, but it's just a tester. Make sure you kind of know your stuff. And this one here. Now, the way to work this, guys, again, is not to freak out as soon as you see it. Work the left-hand bracket until you get a single fraction. Work in here, guys. Keep the signs until you get a single fraction, guys, and then that has to be squared. And finally, guys, go with the right hand bracket, work with that. And again, you'll get a single fraction. And now you add your fractions as normal. Again, guys, if you're freaking out about this, watch the video on Moodle called Fractions Practice. And I have a similar problem to this one worked out in full. So you can see, guys, we kind of move quite quickly. Like we do kind of push things along quite quickly. That's the nature of college. But this is definitely one, like this problem we're looking at here would definitely be one of the most challenging problems you would encounter this semester. So don't think it's going to escalate from here. It doesn't. We back away from fractions now. and we're going to move into different topics, percentages, ratios, stuff like that. So don't worry, guys, if you're thinking, oh, this is just going to get worse and worse. It's not. We back off now. We start walking down the percentages road, and make sure you've got a good grounding on the basics, basic maths associated with percentages. So that's the basis of the next lecture, guys, lecture 6. So thank you for your patience and for watching, and we will chat to you in lecture 6.